Warm welcome you all to channel Meet MIT, that is Math is Tricky. In this video I'm going to share ideas about left hand limit and right hand limit. Okay, so this left hand limit. So left hand limit is it is this limit here which it is for value of x less than a or for a smaller value of x. Suppose, let's take here example, fx is given and we have to find limit at x equals a. Then left hand limit is denoted by, see here the symbol is here, limit x tends to a. As it is left, so right here minus, and fx also next symbol is there, so limit x tends to a and just put here minus 0 and then fx. This is the notation for left hand limit. In case of left hand limit, we always choose the function which is defined for a smaller value of x. I'll be sharing this in problems, with problems also. I'll be making it clear with problems. Let me first explain what is left hand limit and right hand limit. So now next one is here right hand limit. So again, so the right hand limit is it is the limit which is calculated for x greater than a, that is for greater value of x. Okay, so suppose here if fx is the function, and then right hand limit, so right hand limit of fx at x equals a is here denoted by limit x tends to a, and here right hand limit, so right hand limit means it is here always plus fx. Also another symbol we have, limit x tends to a plus 0 fx. Okay, so now let me explain how do we calculate left hand limit and right hand limit. Now remember one more point, a limit will exist, a limit will exist if left hand limit equals right hand limit equals a finite number. Okay, a finite number. It should be a finite number. To exist, it should be left hand limit and right hand limit should be equal, not only equal, they should be giving a finite number. Let me take one example and explain it. So suppose the function is here, let's calculate this, limit x tends to 0 modulus x by x. So how do we calculate this? We know that modulus x equals x if x is greater or equals to 0, and minus x if x is less than 0. Okay, so what we can do here, let's find here left hand limit, so equals limit x tends to 0 minus, so now the smaller value, which is the function which is defined for a smaller value, so a smaller value, so which one is here, limit x tends to 0 minus here, and so smaller is this one, so we'll be choosing this minus x by x when it gives here minus 1. Second one, and right hand limit equals limit x tends to 0 plus we'll choose the function which is defined for greater value of x, so it is simply here, you can see x, so limit x tends to 0 plus x by x, so it is here 1. Although left hand limit and right hand limit are finite number, but they are not equal, so since left hand limit not equals to right hand limit, so we can write here limit x tends to 0 modulus x by x does not exist. So first question is here. So this, let's see here first question, first number, question number 1. So here we are given fx equals ax plus b by x plus 1 and limit x tends to 0, f of x equals 2. Also given here limit x tends to infinity, f of x equals 1. Now we have to prove that f of minus 2 equals 0. How to do this? So for this, first we have to find the value of fx. For fx, to find fx we need here the value of a, then value of b. For this we are given here two conditions. So let's start. First let's find the value of a, then b, and then after getting a and b we will have the value of fx, and then we will get the answer. This is how we are solving. So let's see the solution. For this here we are given limit x tends to 0, f of x equals 2, it is given. So from this we can get here the value of unknowns here. Limit x tends to 0, fx is given to be ax plus b by x plus 1 equals 2. So from this we'll get here limit. So if we put x equals 0, we are not getting any indeterminate form, so direct we can put here. So a into 0 plus b by 0 plus 1 equals 2. From this we got here b equals 2. Now similarly let's find here the value of a. So what is the value of b? We got here b equals 2. Let me write here. Now I'm solving the question to get here a. Let's use here again, we can write here this question. Again we are given here limit x tends to infinity, f of x equals 1. So we can get the value of a from this. So let's use fx is how much? Limit x tends to infinity, f of x is ax plus b by x plus 1 equals 1. And we have the value of b as 2, so we can write here limit x tends to infinity, ax plus 2 by x plus 1 equals 1. And we can see here it is in the form infinity by infinity, so we take highest power common from numerator and denominator, so that we will get the answer. X is common, so a plus 2 by x in numerator, x is again common, so 1 plus 1 by x equals 1. So from this what we will get here, or this x and x cancel, so let's put the value of x as infinity. So a plus 0 by 1 plus 0 equals 1, therefore a equals 1. So this is, now we have the value of a and b as 1 and 2, a and b as 1 and 2. So here let me write here now fx equals here 1, a is 1, so x plus 2 by x plus 1. Now so we can write here f of, therefore f of minus 2 equals here, if we put here x equals minus 2, so minus 2 plus 2 by minus 2 plus 1 equals 0 by minus 1 equals 0. Proved. This is first part. So we have solved first one. Let me solve the second question, and then we'll be solving the next one. So question number 2 for 2. Similarly we can solve. Here again we are given here limit x tends to 0, f of x equals, so minus 6. We are following the same process as in first one. So limit x tends to 0, f of x is given to be x plus 6 by cx minus d equals here minus 6. So again we can see here, if we put x equals 0 in left hand side, it is not getting any indeterminate form, so we can put x equals 0, 0 plus 6 by 0 minus d equals minus 6, or here we can write here 6 equals 6d, therefore d equals 1. Now let's find the value of c. So for that we have given here another condition. So what we can do here, the value of d is here, let me write here d equals 1. Now to find the value of c, let's see here the second condition, x tends to infinity, f of x equals how much, 1 by 3, or we can write here limit x tends to infinity, and then fx is how much, x plus 6 by cx, and d we have got 1 minus 1 equals, it is given to be 1 by 3. So let me write here and solve it. And so again we can see here it is in the form infinity by infinity. So infinity by infinity form is here. So we'll divide numerator and denominator by x, so that we'll be getting here limit x tends to infinity. So it is here x common 1 plus 6 by x, again x common, c minus 1 by x. So x and x cancel, we have 1 by 3 in right hand side. Now let's put x as infinity, so that 1 plus 0, and then c, this is c minus 0 equals 1 by 3. So what we'll get here, 1 by c equals 1 by 3, therefore c equals 3. So now we have the value of fx. So let me write here, and then we will get here. Thus we got here fx equals how much, fx is x plus 6 by c is 3x minus 1. Putting the value of c and d, we have this. Now let's find f of 13. Therefore f of 13 here, f of 13 equals how much, 13 plus 6 by 3 into 13 minus 1. So 13 plus 6, 19, 19 by 3 in 13, 39 minus 1. So we have 19 by 38, and it is 1 by 2. Proved. We have solved this question also. Okay, let me solve another question. Let's move to question number 3. Hope you are understanding this, and if you have any confusion, please write your confusion in comment box. So limit x tends to 0, modulus x equals 0. We are going to prove this. So for this, let's find here left hand limit. We know that we have modulus x equals what? Minus x if x is less than 0, and then x if x is greater or equals to 0. So we can use here concept of left hand limit, right hand limit. So what you will get here, left hand limit equals limit x tends to 0 minus fx, and simply it will be limit x tends to 0 minus fx will be that value which is defined for less than x. So it is here first one minus x, and if you put here, we are getting here 0. And right hand limit will be limit x tends to 0 plus fx, and then it will be the value of fx will be that value which is defined for greater than 0. So it is here limit x tends to 0, and here x, so that will be getting here 0. Now we can see here left hand limit equals right hand limit. So left hand limit equals right hand limit equals 0. Therefore we can write here, so since left hand limit equals right hand limit equals 0, therefore limit x tends to 0 modulus x equals 0. Similarly we can prove the second part. Thank you so much. Hope you are enjoying this video, hope you are understanding this video. If you like this video, don't forget to subscribe my channel and share among your friends. Thank you so much. God bless you. Thank you so much for watching. Thank you so much. Thank you. Thank you so much. Thank you so much. Thank you so much for watching my video. Thank you so much for being with me. And then let's continue this video. Question number 3. Limit. We are going to prove limit x tends to 0 modulus x minus 2 equals 0. Okay, for this, let's find here left hand limit and right hand limit. For that, we need here x minus 2, the value of modulus x minus 2. It is here x minus 2 if x minus x is greater than 2, and then here minus x minus 2 if x is less or equals to 2. So what we'll get here, left hand limit equals limit x tends to, it should be here 2, not 0, it is here 2. Let's correct here, it is 2. So what we'll get here, so it is here simply x tends to minus fx, so we'll be getting here limit x tends to 2 minus, it's for let's choose that value which is less than, defined for less than 2, so it is simply here first one, so it is here this one, then this one, later do the correction. So it is here minus x minus 2, and then what we'll get here, if you put x equals 2 minus 2 minus 2 equals 0. For right hand limit, let's see here, limit x tends to 2 plus and then fx. So now we will take the value which is defined for greater value of x than 2, so it is simply limit x tends to 2 plus and x minus 2. If we put here x equals 2, 2 minus 2 equals 0. So that means left hand limit and right hand limit is 0 in this case. So since right here, since left hand limit equals right hand limit equals 0, we can write here limit x tends to 2 modulus of x minus 2 equals. For this we can see here we have two terms, 1 by x minus 3 minus 9 by x cube minus 3x square. We have to prove this, so let's take here LHS. So LHS will be simply limit x tends to 3, 1 by x minus 3 times 9 by x cube minus 3x square. Okay, so what we can do here, we can take something common from second term and so let's simplify 1 by x minus 3, and then if we take here x square common, so we'll be getting here x minus 3. Now let's simplify further, so that we'll be getting here x, limit x tends to 3. Now LCM is x square times x minus 3, so that x square minus 9 is the numerator, so that after this we can write here limit x tends to 3. Let's use formula a square minus b square for numerator, so that it will be x minus 3 and then x plus 3 by x square times x minus 3. This and this cancel, so we have now, you can see here, now we have here LHS becomes now, how much is it, limit x tends to 3 and then x plus 3 by x square. Now, and it gives here finite number, so we can put x equals 3 to calculate the limit. So 3 plus 3 by 3 square, it is here 6 by 9, 3 2s and 3 3s, so answer is 2 by 3. That's your equals RHS. Good. Hope you understood. Thank you so much. So question number 5 is here. I'm just taking a left hand side. It is here limit x tends to 3 x square plus 9 by x square minus 9, then minus 3 by x minus 3. Thus, let's see here. So what we can do here, in this case limit x tends to 3, let's simplify the denominator first. So x square plus 9 by x minus 3 times x plus 3 using a square minus b square formula, minus 3 by x minus 3. This is our given expression. So now let's simplify further. So let's take the LCM. It is here x minus 3 times x plus 3. So what we are getting here, so after taking LCM we'll be getting x square plus 9 as first term minus 3 times x plus 3. So let's simplify further. X tends to 3, it is simply here x square plus 9 minus 3x and here minus 9. So that will be getting here x minus 3 and x plus 3 denominator. So plus minus cancel. So we are getting here, we can see here, now our left hand side becomes left hand side equals limit x tends to 3. In numerator we are getting here x square minus 3x by x minus 3 and x plus 3 in denominator. Let's see here, still we are getting 0 by 0 form, so further we have to simplify. And so what we can do, we can take x common in numerator so that negative term from numerator and denominator will be cancelled. So let's cancel these two. Let's see here what we are getting after that, x by x plus 3, and we can see here now we are not getting any indeterminate form, so we can put the value of x 3 by 3 plus 3, that is 3 by 6 equals 1 by 2 equals RHS. This is our answer. This is how we have got the answer. Thank you so much for watching. Question number 6 here. The question is here, limit x tends to infinity 2x minus 1, solving this first one, 2x minus 1 power 6 and 3x minus 1 power 4 by 2x plus 1 power 10. So what's how to solve this and what's its answer? So it's very simple. See here, it is taking infinity by infinity form. So in this case what do? Simply we cancel highest power variable from numerator and denominator. So let's take here x common. So 2 plus minus 1 by x for 6, and then x common from second, so it will be 4 3 minus 1 by x. In denominator also let's do the same thing, x, so x power 10, 2 plus 1 by x. Now this we can cancel here, this 6 x power 6, so x power 4, x power 4 here cancel. So now in remaining let's put x as infinity, so 2 minus 1 by infinity power 6, 3 minus 1 by infinity power 4, then by 2 plus 1 by infinity power 10. Okay, so what we are getting, so 2 power 6 into 3 power 4 by 2 power 10, so it will be giving 3 power 4 by here 2 power 4, answer is here 81 by 16. That's the answer. Okay, hope you understood this. Let me solve another problem. Let's move to the second problem, 81 by 16. What's your answer? Now question number 7. Let's see this. So number 7, it is here, limit x tends to 0, 1 plus x power 6 minus 1 by 1 plus x whole square minus 1. Okay, moving to second. So how can we solve this? So just try to change this in the form so that we can use the formula in numerator and denominator. So this is what I'm going to do. Let's write like this, 1 plus x power 6 minus 1 power 6 will divide 1 plus x minus 1. Okay, dividing numerator and denominator by same number, 2 1 power 2 by 1 plus x minus 1. You can see here 1 plus minus 1 will be cancelled, x is here, x also will be cancelled. So what we can do here now, we can use the formula in numerator and denominator. So it will be giving here, for if you use formula for numerator, 6 times 1 power 6 minus 1, and here we are getting here the formula for denominator if we use for this, so 2 times 1 power 2 minus 1, so it is here 6 by 2, answer is 3. That's your answer. Okay, so I have just used the formula, basic formula of limit. This is the formula that I used in this case, limit x tends to a, x power n minus a power n by x minus a equals n a power n minus 1. This is the formula I used. Okay, hope you understood this. Let me take you to the next question, number 8. Let's see here another question. It is, I think, similar to previous one. X tends to a, x plus 2 power 5 by 2 minus a plus 2 power 5 by 2 by x minus a. So again here, let's try to use the previous formula. Limit what we can do here, x tends to a, x plus 2 power 5 by 2 minus a plus 2 power 5 by 2. Just arrange the denominator so that it will goes in formula. Let's write like this, x plus 2 minus a plus 2. After simplification, you can see here we are getting here x plus 2 minus a and minus 2. So this cancelled, we are getting the same thing. So now we can use the formula. So we will be getting here 5 by 2 and then a plus 2 power 5 by 2 minus 1. So that we are getting here 5 by 2 a plus 2 and then power 3 by 2. That's your answer. X tends to 2, x power minus 3 minus 2 power minus 3 whole divided x minus 2. How to solve this? So I think we can use direct formula. Remember this formula, limit x tends to a, x power n minus a power n by x minus a. So our question is in this form, so we can use the formula. Formula is n a power n minus 1. So this is our formula. So let's use formula. So according to this formula, we will be there minus 3 and then 2 power minus 3 minus 1. So what's answer? Minus 3 into 2 to the power minus 4. So answer will be here minus 3 by 2 power 4. So minus 3 by 16. That's your answer. Okay, thank you so much for watching my video, and please always start any question with positive thinking. Yes, we can do, it's easy and it's for us, we can solve this. So let's move to last question. Limit x tends to 0 sine x degree by x. So okay, how to solve this? So for this I'm going to try to use formula limit x tends to theta sine theta by theta equals 1. And in this case, what should we remember? Always remember that theta is measured in radian. Now the question is, here x is given in degree. What about this? So nothing is given here, means it is in radian. So now we need to change this x which is given in degree. So let's write here, let's change the x which is in numerator and which is in degree. So sine x into pi by 180. Now it is in radian. So here this is the formula. Now to use formula we have to balance this. We have to balance this denominator. So we have to write here pi by 180 and then to cut this pi by 180 also we have to write. So now this goes in formula so that it is 1 into pi by 180. So answer is pi by 180. X tends to 0 now, and then hope you understood sine x grade by here x. Suppose this is your question, so how you are going to solve this? Write its answer in comment box.
Thank you so much for watching my video. I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.